Hello, and this is an educational video on X-rays. Now, X-rays are electromagnetic radiation of wavelength 10 to the minus 8 to 10 to the minus 30 meters. Did you know that? I hope you did, because you should know that from last year. However, that's not the end of the story, since there's some overlap in the wavelength range between X-rays and gamma rays. Now, what is the difference, you may ask? Now, that's a brilliant question, and the difference lies in the production methods involved with it. So how can X-rays be produced? The answer is with this device, with the amazingly original name of the X-ray tube. In the X-ray tube, electrons leave the cathode and are accelerated to the anode through a whopping PD of between 50 and 200 kilovolts. When the electrons strike the anode, which is typically made of materials such as tungsten, they decelerate, losing kinetic energy. Some of this energy is lost as the X-rays, which can then emerge from an opening in the tube. This is good news, as we need the X-rays. Unfortunately, most of the kinetic energy is instead transferred to the anode as heat. So, to get past this problem, the anode rotates. Also, spinning objects are very cool. Here you can see the expected spectrum of X-rays emerging from an X-ray tube. As you can hopefully see, it has two main components. First of which is formed when electrons come into the anode and interacts with the electric field of the anode nuclei, causing it to decelerate. This is known as breaking or Bremsstrahlung radiation. The second of which is formed when an electron striking the anode causes an electron, I should say, in the anode to drop to a lower energy level, which releases a photon with a characteristic wavelength. Hence the name of this radiation, characteristic radiation. As we learned last year, intensity is power per unit cross-sectional area. This is important to keep in mind as we talk about X-ray attenuation. Now you may be wondering, what is attenuation? And this is a brilliant question. As X-ray beams pass through matter, the intensity of the beam decreases. This is attenuation. For a collimated beam, that is a beam that is parallel. This follows an exponential decay pattern with the equation below. As you can see, the terms of the equation have been explained below it. Please feel free to pause the video if you need to take a moment to look at it. Of particular importance is the attenuation coefficient, which is in essence how good a material is at absorbing X-rays. Here are the ways in which X-rays can be absorbed. The first of which you should recognise from last year, the photoelectric effect. The other two that you need to be aware of are Compton scattering and pair production. So, just in case you need a reminder, in the photoelectric effect, a single photon is absorbed by an electron and the electron is removed from the atom. In Compton scattering, an electron is also removed, but as well as an electron, a photon of lower energy is released from the atom. In pair production, the X-ray photon disappears and an electron and positron emerges instead. It's not all sunshine and happiness, however, as the positron will likely release another electron and be annihilated. X-ray intensifiers are both cool and important because they can increase the intensity of the light producing the image without needing to increase the X-ray intensity, which can help to keep the patient X-ray exposure to a minimum. It's important to look after yourself after all. It's especially useful in fluoroscopy, where a continuous X-ray beam is used to produce a real-time image. As well as that, it also improves image quality. There are two main intensifier types. The first type of X-ray intensifier is the intensifier screen. These screens are sheets that contain a phosphor, and a phosphor emits several thousand visible light photons for each X-ray photon absorbed. Pretty cool, yeah? So a photographic film is placed between two of these screens, so when X-rays are absorbed by the intensifier screens, the light that comes from the screens then blackens the film, producing an image. The second type of X-ray intensifier is the intensifier tubes. Now, you might guess from all the text on the right that this is a pretty intense subject, so we'll try and help you understand it. So first of all, an X-ray photon hits the phosphor screen. Now, like I said before, phosphor screen, when they're hit by the X-ray photon, release many visible light photons. So these visible light photons then go on to hit a photocathode, which releases electrons through the photoelectric effect. These electrons are then whizzed through a PD of 25 kilovolts, being accelerated, and at the same time are focused by these cylindrical electrons, the lines that you can see at the top and bottom of the diagram. The electrons then hit a second phosphor screen, which produces even more visible light photons. So then you've got all this light coming through, which can be recorded by a camera. The increase in energy through both accelerating the electrons and decreasing the area by focusing these electrons increases the intensity. So contrast media are quite funky substances that can be used to provide contrast between the soft tissues, which can then allow different tissues to be distinguished in an X-ray image. So examples of contrast media include barium meal or iodine. Contrast media have a high proton number. So, as you may remember from before, this means that they also have high attenuation coefficients, making them very good X-ray absorbers. So, the contrast media is ingested or injected into the area of interest, where it gathers along the soft tissue and shows an outline of it on the X-ray image. I sure wouldn't like any inside of me, but I'm sure it's quite useful. Another application of X-rays is computerized axial tomography, or CAT, meow. So, as you can see, the patient is placed in an X-ray detecting ring. So, around this ring we have a rotating X-ray tube. These guys really love their spinning stuff. Yep, rotating X-ray tube exposes the patients to X-rays from all sorts of directions. The X-rays pass through the patient, and the detectors on the other side can detect the X-rays, send electrical signals to a computer, and allowing an image to be formed. A single rotation of this X-ray tube forms a 2D slice, and multiple slices can be used to construct a single 3D image. So it's important to be able to discuss the advantages and disadvantages of CAT scans. After all, why use a CAT scan when there's something better available? So, one advantage of a CAT scan is that it can show 3D images, 3D relationships between different tissues. You will also be able to find that tissues of similar densities and attenuation coefficients can be distinguished due to better soft tissue contrast than a single X-ray image. As well as that, images can also be sorted digitally, which means that it can be viewed easily by doctors in different places. One disadvantage is that it still involves using X-rays, and so still carries the risk involved in using ionizing radiation. Other techniques such as MRI does not involve ionizing radiation and may be less harmful. One other disadvantage is that CAT scans can be quite expensive. Let's be thankful for the NHS. So here concludes the video on X-rays. Don't forget to leave a like and subscribe.